Thin tapes are everywhere in engineering. Insulation, electrical protection, sensor mounting, temporary fixturing, and because they are only tens to hundreds of microns thick, they are often assumed to have no real thermal impact. But in real systems, tape is often placed directly in the heat path, and even a thin layer can add meaningful thermal resistance. Here's the catch. Materials labeled as tape can be completely different in composition. Backing polymers, adhesive chemistry, thickness, compressibility all changes how heat moves through the interface. One aerospace electronics integrator learned this the hard way. They saw unexpected thermal gradients across a PCB, and the cause wasn't the heat sink, the airflow, or the board design. It was the adhesive tape between the PCB and metal standoffs. What seemed like just tape at only 100 microns thick was actively altering thermal performance. To quantify the real thermal resistance of thin adhesive films, Thermtest used the advanced measurement platform MP1 with the patented 1D TRTF thermal resistance thin film module. 3 industry-relevant tapes were tested: Kapton tape, packing tape, and electrical tape. Each tape was tested using a layered stacking approach in a controlled steel sample steel configuration. Tape layers were stacked to increase thickness, and thermal resistance was measured versus thickness, a method aligned with the ASTM D5470 and E1530. Testing was done at room temperature using a 9.9 mm radius TPS sensor. And because the samples were naturally adhesive, no contact agent was needed. Even though these tapes look similar, their thermal conductivity values were very different, with Kapton tape having effective thermal conductivity of 0.132 watts per meter Kelvin, packing tape at 0.18 watts per meter Kelvin, and electrical tape with 0.22 watts per meter Kelvin. Different tape construction led to different thermal behavior. In industries like aerospace, electronics, and advanced manufacturing, thermal margins are slim, and overlooking thin interface layers can lead to hotspots, unexpected temperature rise, and misleading reliability predictions. This study confirms that tape isn't just tape, and assuming bulk polymer values can seriously underestimate thermal resistance at critical interfaces. With the MP1 1D TRTF module, engineers can replace assumptions with real application-specific data and optimize designs with confidence. When thin films sit in the heat path, measurement becomes the difference between guessing and engineering.